Hello everybody, my name is Marwan and today we're going to learn some math. So this video is to help students understand key grade 12 concepts while still keeping in mind past learned concepts. So the question we're looking at today says an amount of chlorine is added to a swimming pool that contains pure water. The concentration of chlorine, C, in the pool at T hours is given by the equation. C at T is equal to 2T over 2 plus T, where C is measured in milligrams per liters. What happens to the concentration of chlorine in the pool during the 24-hour period after the chlorine is added? Now this question has an equation with a rational in it, which means it's referring to Unit 3 rational functions. Another aspect of this question is the fact that we need to find IROC, which stands for instantaneous rate of change. So I'll read the question again, but this time I'm going to highlight some important points. An amount of chlorine is added to a swimming pool that contains pure water. So this is the first part right here. This gives us the situation and what's about to occur in the graph. And then it says the concentration of chlorine, C, in the pool at T hours is given by the equation C at T is equal to 2T over 2 plus T. This is the equation that gives us the graph right here. And it also, we plug in the x's to find the y's in order to find the instantaneous rate of change using this equation. They then say that C is measured in milligrams per liters. This is important to us because it gives us the units in which we have to answer this question. And this is a matter of good form and good communication. Lastly, what happens to the concentration of chlorine in the pool during the 24-hour period after the chlorine is added? So the question we have to answer in order to find the final answer, we have to use the calculations and the diagrams to justify a conclusion. This is the bulk, this is what we're focused on right here. So this question is not one that requires a final answer to be a number, but rather it's asking for the relationship between the concentration of chlorine in the pool and time, which is the 24-hour period. So in order to answer this question, we have to create a plan. So we have to look at our steps. We have 3 simple steps. We inspect the graph, predict the trends, and summarize in context of the problem. We then find IROC at first hour, 12th hour, 24th hour, to justify our trend using numbers, and then we make a concluding statement on the trend. So now we're going to look at the graph and see what it means in context of the problem, which is step 1. So this is a rational function graph, and the reason why there's no negative side to the bottom or to the left is due to the fact that the question is talking about the chlorine being added to the pool at a specific time, which is 0 right here. And then we're trying to find the 24-hour period, the concentration of chlorine at that time, from 0 to 24. So again, this is only the part that we're looking at right here, from 0 to 24. We don't need bottom or left. So we're trying to find the trend for the concentration of chlorine in this graph and time. It's clear for this problem that it's an upward trend and that the line begins to plateau near the end, approaching the asymptote of 2, which is a property for rational functions. We have to understand what this means in context of the problem though. So at 0 beginning, when the chlorine was added to the pool, the concentration increased rapidly, and as the time moved on, the concentration remained increasing but at a slower rate. You can see right here. So now step 2 asks us to explain the problem using numbers. This means that we have to use IROC, which is instantaneous rate of change again. This is a new concept that I'll explain using the graph underneath. In order to understand where IROC comes from, we must use a tangent line. So a tangent line is a straight line or plane that touches a curve at a curved surface at a point, but if extended does not cross it at that point. A tangent is drawn in order to find the slope at an exact moment. So if we're trying to find in the 1st, 12th, or 24th, we have to use a tangent line. You must pick 2 points from that line, find the slope, and that's your IROC. So I'm going to demonstrate how to find, how to draw a tangent actually on the graph. So we're going to look at the graph underneath. I already drew circles at the 1st hour right here, at the 12th hour, and at the 24th hour. So the way you draw a tangent is that you pick the point and then you try to draw a parallel line to the graph while touching the point. So this would be our tangent. We then pick 2 points from there, put them in the slope equation, and then that's our slope, and that's our instantaneous rate of change. So I'll also draw for this one, which will be harder because it's a low slope. You see how it's almost exactly on the line, but it's not actually touching. Same thing with the 24th hour period. We can already make predictions at how, let me draw this again. We can already make predictions at how the slope is going to look like. Increasing a lot, less, even less. And that's it. So for our purposes, we'll find IROC using the equation for a more precise and accurate answer. So the way we do this is, let's say for example, we want the IROC of the first hour. We add 0.001 and subtract 0.001 from 1, and that gives us our x1, x2. So 1.001 and 0.999. What happens is then we can plug these into the equation and find our y's. So c at 1.001, and then we can do 1.001 over 2 plus 1.001. That gives us an answer of 0.667110963. We can then do it for the other point, 0.999, and then we plug it into the equation. And then we get an answer of 0.666222074. I'll take a moment to explain why these are small, very small numbers, and why we need to keep all the digits is because they're very close, and that's how you find the slope. It's the difference between these two small numbers. We then plug this into our slope equation, y2 minus y1 over x2 minus x1 right here, and we get 0.667 ... we can't write the whole number, 0.666 ... over 1.001 and 0.999, and we get a slope of 0.444 repetitive. We can round that to 0.44. We can then write our conclusion statement that therefore IROC at the first hour is 0.44 milligrams per liter per second. Unit analysis is very important. Now we'll go to our 12th hour one up here.
And I wrote out everything. I'll just explain my steps again. We have our equation, we have our 12th hour, we add 0.001, we subtract 0.001, plug into the equation, get y2, get y1, slope equation, we have our slope, we have our concluding statement. We'll now go to our 24th hour one at the top right, and same thing, equation, plus 0.001, minus 0.001, y2, y1, slope equation, we have our slope.
So now that we have our IROC first, 12th, and 24th hour slopes, we finish step 2 and we can get up to step 3, but I'll have to show you what it means in the graph. So we found that IROC here is 0.44. We found that IROC here is 0.02, and we found that IROC here is 0.0006. 0.0006. So what that means is, as you can see, our prediction was right, is that it rapidly increases here and then gets slower as it approaches this asymptote of 2. So we can now finally make a concluding statement about this as we go back to our question. How are we going to make this concluding statement? Well, we looked at the graph, we saw the trends, we saw the number. So we can finally say, during this 24-hour period when the chlorine was added, the concentration rapidly increased. And as we moved closer and closer to the asymptote, which is 2, the concentration got slower. So we can say that we can justify using the numbers. We can say 0.44 milligrams per liter per second was the instantaneous rate of change at the first hour. And at the 12th hour, it's 0.02 milligrams per liter per second. And then at the 24th hour, it's 0.0006 milligram per liter per second. So we can say during the 24-hour period, the chlorine was added, the concentration rapidly increased, and as time moved on, the concentration also increased, but at a slower rate. So now we can look at career options where we can use this in everyday life. Here's some pictures of pool maintenance people. And they use this every time. As you can see their pictures, they're calculating chemical concentrations in the pool. So chlorine is a chemical most often used to keep swimming pools and jacuzzis free of bacteria that can be hazardous to humans. So therefore, this type of problem can be used and can be associated with a career in pool maintenance. When chlorine levels are too high in pool, bacteria can survive and be harmful to humans. Therefore, this type of problem, you need to apply chlorine, can be used every day. Pool maintenance employees measure chemical levels in the pool to make sure it is safe to be in water. Therefore, being a pool maintenance guy, an employee can solve a problem like this. I'd like to thank you very much for listening. I hope you learned how to use IROC to answer questions like this, as well as looking at trends in the graph. I know my teacher taught me well. Thank you.